So today we're going to look at operational amplifiers, or op-amps. So op-amps are pretty important for doing mathematic functions with signals, whether it be addition, subtraction, or just amplifying the signal. So in these first few problems we're going to do, we're going to look at the ideal op-amp approximation. And when we're talking about ideal op-amps, there's three main things you have to remember. The first one is that the voltage at the positive terminal is approximately equal to the voltage at the negative terminal. The second is that the current in to the positive and negative terminal are both equal to 0. And the last is that negative feedback is always used. So to get a good idea of what an op-amp really does and what's going on when you plug it into your circuit, is that it's going to feed back some of the voltage into the negative terminal, and based off of that, the output is going to be set in such a way that the voltage at the positive terminal and the negative terminal are going to be the same. So here's an example of a circuit using op-amps, and a popular question you might get in the future. So on a test or a homework, a professor might ask you, what is this voltage V out equal to? And what is the gain factor? So to start solving for these two things, we're going to go back to our ideal approximations right off the bat. So just to remember them again, V plus equals V minus is the first one. As we can see in this circuit, on the positive terminal, the voltage there is just going to be 6 volts, which is given by this ideal source. And this is because also, since no current is coming into this terminal, there's going to be no voltage drop across this resistor. So everything along this line is just going to be at 6 volts, which also means that everything on the negative terminal here is also going to be 6 volts. So the next thing we want to do is find out what V out is. And since we just said that the voltage across this resistor is 0, since there's no current coming through it and it's not contributing anything to the circuit, this right over here just starts to look like our normal voltage divider rule. And so we can use that equation to solve for V out. So the voltage divider rule says that V minus, which is the same as the voltage across this 2 ohm resistor, is equal to V out times 2 over 2 plus 3, which is just equal to V out times 2 over 5. So doing a little algebra, we can find that V out equals 15 volts. So the second part of the question asks, what is the gain factor of this circuit? So the gain factor is just defined as being equal to the output voltage over the input voltage. So in this case, our output voltage is 15 volts, and our input voltage was 6 volts. So that means so that right there is our gain factor, 15 over 6. So here's another possible setup for an op-amp. So once again, let's try and find what's V out and what's the gain factor. So looking at this again, we can see that the voltage across the positive terminal here is just going to be 0. Because even though there's this 27 ohm resistor, it's all connected to ground, and there's no current flowing through here, because our approximations say there's no current going into this terminal. So if we know that V plus is equal to 0 volts, that means that V minus also equals 0 volts. So our next step would be to pull KCL right here at this node, at the V minus area. So KCL at V minus. So the current going into this node from the left hand side is the voltage here, which is 7 volts, minus the voltage at V minus, 7 minus V minus, over the resistance, which is 10. The voltage coming out of this node is the voltage at V minus the voltage coming out, V out, over the resistance, which is 5. Since we just said that V minus was 0, this simplifies to 7 over 10, which equals minus V out over 5. So doing that, we can just solve for V out now. So V out comes out to be minus 3.5. Alright, so now, solving for the gain factor. The gain factor is voltage out over voltage of the source, which is just minus 3.5 over 7, which is just minus 1/2. So this quantity is dimensionless, but over here we have to remember our units on V0, which just is volts.